we need to show the derivative of y with respect to x as given by x over y whenever x and y are given in its parametric form. That means both of them depend on the parameter t. So let's begin with our function x. So here we have x equals to a multiplied to t plus 1 over t. So what we'll do, we'll take the derivative on both sides with respect to t. So we have derivative of x with respect to t equals to a is a constant. So a will get multiplied to derivative with respect to t of t plus 1 over t. So this is going to give us a multiplied to, so derivative of t with respect to t, that's equals to 1. And we have derivative of 1 over t, so that's negative 1 over t squared. So this is the value of derivative of x with respect to t. Fine. Now we'll come to our function y, which is given as a multiplied to t minus 1 over t. We'll take the derivative on both sides with respect to t. So this gives us derivative of y with respect to t equals to a multiplied to derivative of t with respect to t. So that's 1. Derivative of 1 over t is negative 1 over t squared. Since we already have a minus sign here, this will become 1 over positive t squared. Fine. Then what we'll do, we'll find out derivative of y with respect to x. All we have to do is take derivative of y with respect to t and divide it with derivative of x with respect to t. So this will be equals to a multiplied to 1 plus 1 over t squared divided by a multiplied to 1 minus 1 over t squared. So this gives us, so here a and a gets cancelled. We're going to multiply both numerator and the denominator with t. So we get t squared plus 1 divided by t squared minus 1. Now, if we consider x and y, so if we divide x with y, so for x we have a multiplied to t plus 1 over t, and y it's a multiplied to t minus 1 over t. So clearly a and a gets cancelled out, and if we multiply both numerator and the denominator with t, so we will get t squared plus 1 divided by t squared minus 1. So this is exactly what we obtained for dy over dx. Now that means we can say that derivative of y with respect to x, this is also equivalent to x over y, and this is what we had to show, hence proved.